Welcome to our competency-based questions for class 10th physics designed to enhance your conceptual learning. Question 8. In the human eye, the distance between the lens and the retina is 17 millimeter. Light entering the eye is refracted first at the cornea and then at the eye lens. The ciliary muscles can control the focal length of the lens by changing its shape. We need to answer the three parts. So let's take part A. Dinah is looking at the moon. What is the focal length of the combination of the cornea and the eye lens at this time? So let us have a closer look at the scenario given to us with the diagram. So this is the diagram that is given to us. The distance between the retina and the eye lens, it is 17 millimeter. And we all know that at retina, image is formed. So in other words, this is the distance between the lens and the image, and that can be denoted as V. So image distance V, it is given to us as 17 millimeter, or it is equal to 1.7 centimeter. And since Dinah is looking at the moon, we can say that object is moon and it is located at infinity. So the object distance U, it can be denoted as infinity. We need to find the focal length of the lens. So that can be obtained by using lens formula. So using lens formula, we can write 1 upon f is equal to 1 upon v minus 1 upon u. And that can further be solved as 1 upon f is equal to 1 upon 1.7 minus 1 upon infinity. And infinity, 1 upon infinity is 0. So we can write 1 upon f is equal to 1 divided by 1.7. Using 1 upon infinity is 0. And this implies f is equal to 1.7 centimeter, or we can write it as 17 millimeter. So this is the focal length of the lens, in which the distance between the lens and the retina is 17 millimeter. But this focal length is when the object is placed at infinity. If the distance of object is changed, the focal length can be changed, and we all know that can be achieved by ciliary muscles. So part A is done. Let's take part B. So in part B, it says Dinah is reading a book kept at a distance of 20 centimeter from her eyes. What is the focal length of the combination of the cornea and the eye lens at this time? So now the object distance is changed, and due to that, the focal length will also change. So we can write it in this manner, that U here is minus 20 centimeter. And the image distance, it is already given to us, that the lens and the retina, they are at a distance of 17 millimeter, or we can write it as 1.7 centimeter. So V is 1.7 centimeter. Again, we can use the lens formula. Using lens formula, we can write 1 upon f is equal to 1 upon v minus 1 upon u. And that can be written as 1 divided by 1.7 plus 1 upon 20. That can be written as 1 upon 1.7 is 0.588 plus 1 upon 20 is 0.05. So when we add it up, it becomes equal to 0.638. That is the value of 1 by f. And on taking the reciprocal, f will become equal to inverse of 0.638, and that is equal to 1.57 centimeter. And in millimeters, we can write it as 15.7 millimeters. Let's take part C of the question. In part C, it says, when Dinah brings the book closer to her eyes, the letter appear blurry and she cannot read the book. Explain why the letters appear blurry to her. So we can understand this with the help of this diagram. When the object is brought closer, then what will happen that up to a certain extent, our eye is able to adjust the focal length of the lens and we are able to see the image on the retina. That is up to the near point of eye. But beyond that, what will happen when you bring the object closer, then the near point, then the image will fall behind the retina. And in that case, the letters will appear blurry to us. So when the object is brought very much closer to the eyes, then the image is not falling on the retina, but it is falling behind the retina, and that's why the letter appear blurry. And that's the answer for this question. Thank you. Keep learning, keep practicing, keep excelling.